a default package. So once we start our studio, we have it already. So it means that you can just start with the checkway data without necessarily doing library data sets, but you can say so in your in your solutions, right, to the question. But the first question, so you can read the preamble. It says about some farm, they record, I think, the time and weight and the particular chick and the diet they are on. Okay, so we first ask you that the farm manager wants to study the growth of chicks between day 4 and day 12. So to do this, you first need to inspect. Once we are talking to you about something like this, what you need to do is to inspect, okay, the data so that you really understand what the question is about. Okay, so tutorial. I have to be alternating between the question, but I think all of you have it. So I'll rather now, because I want to do it, I'll go through the I'll show my house video. So basically, what you need to do is to just look at the structure of the data. So let me share my screen again, but in this case the our studio. Okay, so tutorial. Okay, so what we need to do is to get the, how do we get to know the check weight? So I can just start with check weight is this one. Remember that I said it's already check weight. So I do like this. It tells you about the description of the data, but I can do the head of it, right? Head of check weight to see how this data look like. Okay, and it looks like this. So you have check the weight, you have the time. Time is actually in days if you look at it over here, since birth, right? Okay, so what do I do? Now I know that it is being done 0 to 4, 6, 10 and 12. Okay, if I want to check all of it, you see,
Please,
so
you can't hear anything.
you can't hear anything. Hello. Oh, okay, sorry. So all this while I was on mute and nobody said it. Thank you. Okay. All right. So this is the entire data, but it's long. I think 500 or so. So you won't see all of them. But basically, what you look at is that the time moves from what? 0 to day 21. Okay, so in the first question, you realize that I was asking you, right, to that the manager or whatever. Just a moment, I want to get the question printed over here. Just a moment. Two-sided. Okay, good. Okay, all right. Okay. So we asked, the farm manager wants to study the growth of chicks between day 4 to day 12. And I said randomly select 2 days, right, for this exercise and show your outcomes and results, right? So first in A, what do I want you to do? Look at the time. So you see 0, 2, 4, 6. So it means that the farm manager wants to study, let's say, day 4 to day 12. But I want you to select two. I want you to select what? 2 points from here. So what do? Well, so what you can do is so many. I mean, there are several ways to do this, right? Okay, but I want to be just to make sure that I don't complicate things. Let's go on. Okay, so basically what I'm saying is that you need to select 2 to 12. So if you look at this, it's simple. So the time, if I want to look at time as this, I can select all the times. Okay, check weight, time, right? Okay. Now, if I do this, it's going to select all. Oh, sorry. I should have come down a bit. Okay. It's going to select all the time. So I'll get a long vector if I look at it. But that's not what I want. All I want is for the
Sir.
yes. Yes, please go on.
Please, we can't see your
You can't see
screen.
my screen. Are you doing it on a mobile phone?
No, sir.
I'm sure the others will see. Maybe you have to unjoin a region because I'm actually sharing the screen. Okay, so let's move on. Okay, so basically I can select if I look at this one. Okay, all I want is this. So if I look at this, one way to do this is that I can select the third, fourth, fifth, sixth, seventh. So I can say that the time that I want to do is 3 to 7, like this, right? Okay. Now if I do this, I'm going to get only that one. 4, 6, 8, 10, up to 12. Out of this, I want to select only 2. So 2. So if I name it day 2, it means I'll just sample time, okay, and then size is equal to what? 2. Okay, 2, so rather like this, right? Okay. So this selected, if I do it again, I'm going to get different samples. You see, 10 and 8. Okay, so it depends. Each of you will get maybe different values. So basically that's the A part. And there, what am I looking at? I just want to check whether you can do random sampling. That's all. Okay. Then we move on to B. Please ask any question. This is just one way of doing it. It's not the only way. You can have different ways, right, of doing the same thing. Okay. So when we are marking, it's not like we... And please, you can pick your script. Tomorrow, we needed to cross-check what you submitted on Sakai. So I do that all the time. That also check to see those who are trying to cheat the system. So forgive me, we had not done that exercise before I said you should come for it. Okay, so let's move on. Now, B was that you need to select the corresponding, the data corresponding to the 2 time points you randomly selected in A. Okay, so what I wanted you to do was to what? Be able to find all the cheek weight with time equal to what? To either what you selected. So in my case, the last one is 6 to 12. So what do I do? Well, I can say that, or let's say my sample data is, or let me name it, maybe day 2 data. Day 2 data will be, I mean, there are different ways. You can use subscripting, or that we taught, or the subset, whichever one you want to. So it's day 6, right, and day 12. So maybe let me name it. Day 6 will then be, let's say, if you want to use a subset, okay, we will subset what? Check weight. So all check weight data with, we are subsetting with check weight time equal to what? Day 2. So I can say day 2 what? 1. If you don't want to, because if I do it this way, then anytime I go back and run day 2, I can select but it may not be day 6, which means, so look at this. So if you look at what I've selected, you see that the time, every observation there is 6. So that's it. Now, another way to do this would have been that I use the subscripting, right? So that one, if I want to do so, I can also do so like this. So usually there are different ways of achieving the same results in R, right? Okay, so yeah. So another way could be that I use check weight, right? Then I use this, right? And then I select, we did some of this in class. So all rows with this. So if I run this as well, okay, so yeah, so you see I've gotten the same thing. It's the same results. All of it has time equal to 6. So any of this will help you achieve the same result. Okay. Similarly, I can get that of day 12. So all I have to do is to change this to what? To day 12. Okay. And it means here I'm going to use 2, right? Okay. So if I do this and I select day 12, everything over there is 12. Please, is everybody okay with this? So that's how you go through this. Okay. Any question on this? Other than that, I move on to C. What was the C about? Well, yeah. And then how do you report this, right? Remember that I said show the first few rows. So I don't want you to be, taking all this, right, into your work, the one you are presenting. So if I want you to do something like this, all you need to do, if you want to show the results, even if you copy all of them, you need to delete. So let's assume you copy this and you want to show this in Word. Okay. What do I want you to do? Just give me, let's say, the first, either you use head to give me the first few rows, or you can, let's assume, I'll show you my Word document soon. Okay. So so this is a word. So I have copied whatever I got here. Okay. All I'll do is that I'll delete all this, okay, up to, let's say, the second one. And then I put dot like this. So in that case, you don't waste my space. So this is my results to show that I have day 12. Okay. Please, are you okay with this? So please don't copy so long a data to show me. I mean, you've given us the code, okay, and also let's say here, you've given us the code. So all I want to see is that you've given me some results, okay, to show that, I mean, you've done that work. So that's it. You don't need to show or the data set. Please, have I made myself clear? Okay. And this, you put all of them. If you remember, I said all this will be in Korean name. So like that, and then it looks nice. Everything will be nice. But your results, if I want to talk about the data, I'll use maybe Times New Roman. And that's how I want you to do your stuff. It makes it nicer to look at. Okay, so maybe the data above shows the results for chicks at day 12, something like that. So you see that the font sizes are different, right? They are not the same. Okay, so that's how I want you to present your work. So please, when you go to UGCS for your final practical exams, I don't want to see everything because I'll be awarding marks for all this. Okay, you cannot read a book and then you have your R codes just like the write-up. It's not done. Okay, so please do it now so that when you find yourself in a master's program or somewhere, you do it well. Yeah. May tutorial. 200. Okay. All right. Okay. So that's it. Okay. Please, if you have any question, please ask. Okay. Stop me at any point in time if you want a question. You want to ask a question. Okay.
Sir,
Yes.
please, the code, which fonts did you say it should be in?
It is Korean name.
I didn't get
There it is. Font
Okay.
name. Korean name. Okay. That's it. That the one you see at the top. Okay. Okay. And the codes and your results should be in that. But the narratives that can be in Times New Roman. Yeah. Okay. Okay, good.
Okay.
So let's move on if we don't have any question. What is the next one? Well, next is C. What is C? It says display box plots for the weight of chicks for the time points you selected. Comment on your result. So here we are only interested in the weight of the chicks. Okay, so if I want, I can put them in one like a data frame, right? Okay, so and then I'll take the six weights. Okay, I can name it weights day 6 is equal to that. And then why am I doing this? Because I want to make sure that the weight day 12 I'll get a side-by-side plot. So box plot. Okay, so that's it. Then I have my weight data, so I can just do a box plot. Okay, and just the weight, because weight, let me show you the weight. Okay, so it gives you only the weight, the corresponding weight for each day 6 and then day. So the first check weighs 64 in the day 6. In day 12, it weighed what? 106. Now, if we are conducting a t-test for this, what will it be? What kind of test can we use to check whether there has been a significant increase in the weight of the chicks? So this is more or less like your 223 as well. If you were to be asked to conduct a test, we actually ask you to conduct this test, I think, later on. What do you think will be the test? What test will you use? First of all, if it is 223, you have to check the sample size. In this case, your sample size is what? 49. So, assuming you don't know anything about the population standard deviation, what will be the test, the prescribed test you will use? Please.
Use the t-test.
Which of them?
The t-test.
Are you sure you use t-test? What is your justification?
It's a test.
That's what?
Use the Z.
You use the Z. Why?
Yes. Because n is greater than 30.
Okay. So basically, we can consider this as what? A large sample, right? So regardless of what we know or don't know about sigma, we can still approximate it with the Z test. Right. Okay. So that's it. But what will it be? We haven't still finished. How will you do this test? You've done one step of knowing whether it's the distribution will be normal or a T, right? Look at the data. Well, you have chicks, let's say 49 chicks. You weigh them at day 6, and then they will be feeding on a particular feed, and then you weigh them at day 12. So if you want to check whether there has been a significant increase in their weight, what kind of test are you supposed to do?
A paired test.
Yeah, this is paired. That's what I'm looking for you to say. It's paired. Okay, it's paired test. Is everybody okay with this? So that's it. Display your box plot, and then so that's our box plot, and then we say comment on it. So how do you comment on this? This one you need to provide label for the Y, and Y will be what? Weight. And you can go to the health house and check what weight is measured in grams. Then you put in grams. Okay, so that's how you look at it. And you can also go to what? The S lab. S lab will be what? Day. Okay, or time. Day or time. Maybe time will be better. Okay, so something like that. So this shows, and how are you going to comment on this? Or if you want to now, usually when you copy it like this, it's a bit, let me see, sometimes it doesn't work well because you see it to be too large when you put it in. Okay, this works. I think if you copy it as meta file, it works. So you see the way some of you were struggling to do this. So you can just copy, and then you copy it as meta file. If it is bitmap, it becomes so big. So you copy plot, you go to your Word, and then you paste. So let me alternate between this. So I'm going to show my Word. So I just come here, Control Z, I paste it. Then I now want you to comment on it. So if we say comment on this, what do we want you to do? Well, we want you to give. So for example, this one, we will say that the box plot, okay, so the box plot shows that chicks, the weight of chicks, the box plot shows that the weight of chicks at, let's say, day 6 is significantly less than the 12. Okay, so I mean I can say this, or I say that the 12, the weight of chicks, or as time goes on, the chicks what? They have what? They increase in weight. Okay, so if you look at all these, even the lower quartile over here is greater than all the values in day 6. So I can talk about something, but it's not statistical significant, right? We haven't done that test at all. Okay, so even the use of significant tests, not maybe, or the way, let's say, I can say the weight of chicks at day 6 are less than day 12. So that's okay, rather than bringing significance over there. Okay. So that basically, that's the comment on the graph like this. So you see that the 12, they weigh more than that. Okay, so that's what we expect from you when we ask of something like that. Okay, any question again? Please, are you okay? So that's it for C. Then we go to D. If you have question, please, you draw my attention before we move on. Is it reasonable to statistically conclude that the average weight of chicks is significantly different at the 2-time point? So that's the question that I asked. So in this case, we know already. Remember that now we are going to use t-test, even though we say it will really be what? A z-test. Okay. So it looks like this. So we copy this, we paste, right? Like this. So X, what is X? Because I have already done weight, I can just bring the weight, okay, and I say day 6, okay, then weight again, and I use day 12, right? Okay, the alternative. So this one, what will be the alternative? What do you think will be the alternative?
To be less than.
Less than. Okay. I said significantly different. Okay, so this, I won't penalize you if you use even two-sided because of the way the wording I provided. But in a proper test, you will be checking whether it is less than. Okay, because X is the day 6 and then Y is day 2. Mu will be 0. Paired, what is paired?
True.
True. Yeah.
True.
True. Okay. var dot equal. This we can't say it. So what we needed to do is to test first. Do you remember? We need to test first to see. So before I do that, because it's two-sided, we need to test. And what do? We use var dot test, right? var dot test to check whether the variances are the same before we can provide that value. So we check this. It's F test for the two, the confidence interval. If the variances are the same, I expect the ratio of the variances to be equal to 1. Now, this does not include 1. So what do I say? The true variance is not equal to 1, meaning they are not the same. So it means that my var dot equal will be what? False, just like it's there, but I've provided justification for it. Okay, so please take note of that if you are doing this, and we can even check as well to see whether the assumptions are satisfied, normality, and so forth. Okay, but I won't waste my time, too much of your time here, so let's just move on with it. We assume that normality is satisfied. So we perform our pair t-test, okay, and this is the data and so forth. Okay, less than. So here, if I'm using the confidence interval, I'm checking whether the interval includes 0. Does this include 0? In 223, you would have said that H naught will be, in this case, mu, do you remember, mu subscript D will be equal to 0, and then H1 will be mu subscript D is what? Less than 0. So that's a hypothesis we are testing. Okay, so we want the confidence interval to contain 0. It doesn't. So what do? We reject the null hypothesis. If we use p-value, that's also very small. So what do? Reject the null hypothesis. We can also read from tables, which is what you do in 223. So in this case, by here we can read it from tables. So QTP is equal to 0.95, right? And then DF is equal to 48. Here I need to use 0.05 because I'm reading it on the other side of the graph, okay, so that I get negative. So this is it. So this is what you will read if they give you tables in your 223 exam, right? So you go to the T table, you look, and this is one-sided. That's why I'm using 0.05. If it was two-sided, I was going to use 0.025, right? Okay. So you go and read this, and then you check. So which one, in this case, the rejection region will be that we reject for small values because mu D is less than 0. We will reject for small values of T. So you consider the T you computed from your data, that is negative 14.09. And the one we read from tables is negative 1.64. Now, which do you reject or you fail to reject the null hypothesis? Please.
We reject.
We reject. Why?
Reject.
Why? Why are you rejecting? Using the test statistics, why are you rejecting?
So we fail to reject because using the T,
Yeah.
the test statistics is less than the critical value.
Yeah, that's it. So that's it, and then you continue. So whichever way we look at it, we are still going to reject. But if you reject this, what does it mean in practice in relation to the problem we are dealing with? Please continue. How are you going to interpret this in relation to the problem we are dealing with?
It means the difference the difference is less than 0. The difference between rates day 6 and day 12 is less than 0.
Which means in practice, what does that mean?
Meaning the difference are not equal.
Yes, but you are not interpreting it in a layman's term. So, all right, what are you going to tell the farm manager?
Okay.
That's what I'm looking for. Who was the one talking?
So please, it's me.
Your name?
Okay. Mawulawe.
Okay. Yes. So, what will your message to the farm manager? That's what I want. What you are saying is statistics, but you need to interpret it in relation to the problem, and then the takeaway for the farm manager.
Okay.
Remember the problem they are doing. They are measuring the time. Each time they measure the weight. So from day 6 to day 12, what can you tell the farm manager?
They are equal.
No, you said there's a difference.
Hello.
Yes. Oh, please, let's hurry up. You have the question. What does it mean? Yes, go on, Abdul Karim. If you want to talk, just go on.
It means that the chicks which are weighed on day 12, their weight is greater than those of day 6.
Look at the question well. Is it the same chicks or they go and take different chicks?
It's the same.
The same. So interpret it well.
Same thing. Okay.
You have chicks, you are always looking at them, and day 2 you go and weigh them, day 4 you go and weigh them, day 6 you go up to 12, and you have checked whether there is significant difference between them. There is. So what do you tell the farm manager? Yes, please go on. Just go on if you want to talk. You just mention your name and then you proceed. Let's hurry up. It's almost 9. Hurry up. I also need to go home and rest. So hurry up. We haven't finished. We have more things to do.
Sir,
Yes.
please, there's a significant difference between the two weights on the different time. So, when the chick is measured on the 6th day, it is lesser than the same chick being weighed on day 12.
You are talking about the average, right? Yeah. So in other
Yes,
ways,
sir.
you can say that the chicks their weights are increasing significantly between the two
Yes,
time
sir.
points. Yeah. So if you explain it to a farmer like that, they will understand. In other words, your expectation is that, at a later date, they will grow for you to be able to sell and get much money, something like that. Okay. All right. So let's move on. At least now we all have an idea of what this will be. Okay. So please, it's important that you are able to explain your statistics to a layman. Is that okay? Yeah, and that should be devoid of statistical terms. So speak in a way. Write your own function to find the Spearman's rank correlation coefficient between. I think we have done it in class, isn't it?
Hey, no, sir.
No,
Are you sure?
it wasn't this.
No.
Yes, sir. No, sir. We didn't do it.
But
Okay.
you expect us to do everything, eh?
Yes, sir.
Hey,
Yes, sir.
my dear friends, it doesn't work like that.
You see, at the second class.
Okay, so remember that we said that this is the structure of function. It should have a name. It should have the keyword function. For correlation, we need x and y. So you need something like that, right? Okay, so if I have this, you remember the Spearman rank correlation coefficient? The formula. So we need, it's what? 1 minus 6 sigma di squared divided by n into n squared minus 1. We know this in level 100, right? Okay. Now, so what do? We need R, let's say Rx will be the rank of X. I asked you to check, what do we call it? There's if you check the YouTube page, my YouTube page, you will see that there's what do we call it? A video on ordering, ranking, and what? Yeah, ordering and rankings in R or something like that. So check. It's just about 15 minutes or 30 minutes video. I've done all these, how to order, how to rank, and so forth, and how to sort. Yeah, ordering, ranking, and sorting it now. So remember that you need this, right? Then the D is the rank of X minus what? The rank of Y. Do you remember this? Level 100. Okay. So then I can, Spearman, I can calculate this at 1 minus what? Let's say I can get my N. N will be length of what? This one, because there's correlation, it has to be of the same length, right? Okay. So something like that. Then the Spearman will be 1 into bracket. Then I have 6 times sigma di squared. So sigma is sum, right? So then I have d squared. Okay. Then I divide all these by what? By into bracket again, n squared, right? Sorry, it's n times what? N squared. Oh, sorry, n raised to the power 2 minus 1, right? Okay. If I like, I can put all this in bracket because you are subtracting all that from 1. Okay. Then I can return maybe SP. How many? Let's say I want digits. So I want 3 decimal places. Oh, sorry. I need to round. I want to round it. Okay, round. Let's say SP digits 3. Okay. So that's it. This is a simple Spearman correlation coefficient. So I can check this on the data set we did, which is X is weight day 6, and then Y will be weight day 12, right? Like this. Okay, so that's it. That's our Spearman correlation. Okay, so that's E. Then F, I asked you to use the inbuilt function. Do you remember the inbuilt function we used? It was call, right? So call. Okay, call, and you can use Spearman. So we can come here and get call. You copy this, right? And then remember that we need this, so I can just copy and paste in here. Okay. Use everything. We don't need it. I can take it off so that I use the default. Method will be Pearson. Spearman, sorry. So I take everything off. I leave this one like that. And then I run it. Okay. Are they the same? That's what G talks about. Are they the same? Yes. Yes, both functions give the same result. And that finished. We are done. Oh, we said 4 decimal places. Sorry. So it means here will be 4. And yeah, here I can put it in round as well and say that digits, that's the full meaning. You can say digits equal to 4, like that. Okay, so yeah, okay. So and then this one, I need to rerun it again. Yeah, and then I run this as well. There we go. So yeah, there's some slight difference, but not that much. Okay, up to 3 decimal places, they give us the same results. Yeah. So we can say approximately the same. Give approximately the same results. Please, do you have any question? So I'll make this available to you as well as the recording of this class. Okay. So yeah, any question? I wanted to stop exactly at 1 hour, so let me quickly try and do question 2. I may not finish with all of them, but at least I've done. Should I praise myself that I've done well? Okay. Question 2. Please, any question on 1?
How this
No,
you
sir.
call it?
Any question?
Yeah.
No, sir.
You the
Okay, let's move on. Okay. Then the B.
Yes, sir.
B was about the survey data. So you see this one, you need to, I said it's in package math. So you see I'm doing question mark, nothing is done. So you need to go to math, or in this case, you have to, for you to answer, you need to do library what? Math. Okay. Then after that, you get survey. I think we look at this data as well in class. So nothing is new over here. And in the exam, I'm going to do the same. I'm going to, I mean, this one, if I give you even the same question, you need to work it out. So, but I'm not going to give you the same question. So, okay, so the description, how do you get a description? This is the description of the data. So it's a data set. So you can either copy this or, formulate it in your own ways and put it. So that's the A part. Not quite difficult. Okay, so that's A. Please, are we okay? So that's A. Then B. B is, what are the dimensions? How do we get the dimensions of the data? Well, we can use dim, which is dimensions, dim of survey. Okay. Now, if you look at it, you can also get it from, I think, the structure. If you look at the structure, it will also give you an indication of the so there it is, 237 observation of what, 12 variables. So it will also give you 237. So you can use any of this to get through to tell us about your dimension. C. Construct a contingency table for how often students exercise. So you need to come to here and check. So you see how often a student exercise. I use this one. So I use the description. So the variable is like exercise, right? And then how much the student smokes. So that's smoke. So how do I do this? We all saw it. C, let's say C tab, the contingency table is table. Okay. And then we call survey. We select exercise. And then we call survey again. We select what? Smoke, like this. So we do this, and that's our contingency table. Like that, okay? And then use, that's it for our C. So we copy this, the code and the results into our Word document, and that's it. We are done. Then D. Please, if I may be moving fast, but as I said, I'll give you the recording and also the script, and then you can take your time and go through it. Okay. It's late. We must have some sleep. Use the bar chart to display. So I'm not going to complete all of them, but we did this in class, right? So if I do bar chart. Okay, bar plot of C tab. Okay, and of course you can go in. So something like this, and then we can color. Okay, so this one we have 3 colors. So I can do 1, 2, 2, 4, something like that. Okay, so, and then you give the legends. We've talked about this, right? So let me leave it as an assignment for you. We've done some in class, so I'm sure most of you will be able to do it. But you need to provide a legend so that it shows over there. And then E. So lastly, E is that, sorry, you need to also comment on your results. So here we say that most of the students have not what? Never smoked. Okay. Then you now go to never smoked. Most of them have never smoked before. Hey, you have to check. I hope I'm getting the right. Okay, yeah, smoke, yeah, never, yeah, okay. So never smoked, yeah. So we are right, okay. And then within that, you realize I think the red 84 and 87. You realize that the frequencies, those are also the two frequent, and also some also dominate the entire result. So you can use something like that to describe it. You don't need to go through each block and talk about it. You can just look at one, and also if you look at all of them, for the other one you could see that the frequent, okay, are usually on the high side. Okay, so yeah, the other ones, if you look at even frequency over here, you see that this one 7 and not 3, 87 is greater than all of them. Occasionally is greater than all of them, and then 9 so greater. So you can also use that one to express or to comment on the graph and so forth. And then E, I want you to do a chi-square test, and we talked about this. So this is chi-square test, and then you put in your C tab, right? Okay, and then you get your results. Okay, so some of the and this is true. If you remember, I talked about it. The chi-square test is appropriate if the cells contains at least 5. Okay, but you see that 1, 1, 1, and 3 and 4 are in, so that's why the approximation may be incorrect. Okay, so the proper thing to do is to use the Fisher's exact test, and you do some of this when you do categorical data analysis later on, I think in your level 400 or so. So that's it. Okay, so here the p-value is what? Large, so we'll say that there's no what? Because here we say that H naught, and you do this in 223. So you say that there's no dependency between what? Between smoking habit and what? And exercise regime for students. Okay. Whereas H1 will be that there exists what? Some relationship or dependency between what? Your exercise and smoking habit. Okay, but in this case, we fail to reject H naught, which means there's no dependency or relationship between the two variables. And that brings us to the end of the class. Exactly 9 p.m. Okay, any question before we call it a night? Any question? Yes.
The date for the exam.
The last, I think the last first day after the main exam. If I don't get a slot, we'll do it the second day. So it's when is your last? I think it's March something. Is it March 9th? Yeah, we will check. I think March 9th will be the last day for the main exam. So when they start the recits, then we do it. Is that okay?
Okay, sir.
Yeah.
Yeah, I'm fixing the date.
So once I'll get a date out for you anyway. So, but once we start the recits, we will have the